So today we are running some 20 gauge and 60 gauge stainless steel sheared parts. They always have on one side they have the shear burr and then the other side is round. That actually has a shear burr on 3 sides. It may have come from a punch. This is good. But we need to run both sides, also the coated side. The blue PVC coating is the 60 gauge and the red PVC coating is the 20 gauge. We are here on a single-sided machine, but the results will be the same on a double-sided machine. BM1600C, very wide machine, of course. And we are currently running at 11 feet per minute. I'm going to reduce that a little bit to 10 feet per minute. And we made a table, you see down here, where we measured out exactly where we have which feed rate based on the potentiometer. I'm going to give it a little bit more pressure, slightly. And so we are in the conveyor belt, but we are not going to differentiate between the 60 gauge and the 20 gauge because it really doesn't make that much of a difference. Really. We are with our cross belt in the conveyor anyway. We couldn't go much harder without doing damage to that. And so the result. Of course, in the 20 gauge you'll see a little bit less result than in the 60 gauge where we make more pressure. You see we have good edge rounding all the way around here. That may be too much for what you're looking for. We have a little bit less here, but that's still a very good edge. It has no sharpness to it. And then we do anything on the reverse side. Again, we have a burr. No burr here, burr here, burr here, burr here. And then no burr here, no burr here, no burr here for funny reasons, and no burr here. So only burr here. And there we have pretty much 3 sides with the burr. Right. Could be that way. So, and then we're going to repeat that test for 8 feet and for 6 feet a minute. And for the PVC, we're probably going to lighten up a little. So here now we have good edges all the way around. Of course we have less edge rounding where the burr was than where we didn't have a burr. But this is all the way around, very round here where we didn't have a burr. So we're going to write this here. This was 10 feet per minute, medium pressure. And it was our standard 4060 block. Standard 4060 block means it's a regular aluminum oxide block. And there's always one block 60 grit and one block 40 grit alternating, so that you have, that's really relevant for people who run inside contours as well. So if you never have holes, you might as well also run simply 40 grit if you think that's better, which gives you a little bit more aggression on the outside. But our standard setup is a 4060 grit. Pressure, standard 40 grit. So going forward, we're going to abbreviate like this. All right. So let's do a little bit different here. We also ran some parts before with a ceramic block, and I'm going to run some more parts with that. So now we're going to go down on the 16 gauge and on the 24 gauge on the good side, we are going to go down to 8 feet per minute. We call that speed of 5 and 6 about here. Right? So you can do that as well. Notice that I put the part at an angle because it's not going to cross-grain your material because you have PVC coating on the free-grain side, on the back side it doesn't really matter. But foaming at an angle gives you the best result. If you have longer parts afterwards, you can do that too. The results are still going to be comparable, just a little bit less on the shorter side. And again, now you see those radius increase. A little bit less here in the thinner material, right? But now we are going to go just with the thinner material here for the PVC side. Now that we are going slower, and for the thicker material, I'm actually going to up the block a little bit by about half a millimeter to reduce the pressure, so that we are not taking too much of the PVC away. So here now you see at 8 feet a minute, you see how we are getting into the PVC and we are really hitting the metal, which means it's rounding it. But hold it not to do too much here. This is the setting for the cross bell. We are just going to go up a half a millimeter, which is a quarter of a turn. Same speed, 8 feet a minute. So 8 feet per minute, medium pressure, and a standard 40-60 block. So you see here we have a very comparable result as to how we hit the edge, maybe still a tad more, but that's perfect for what you want to do. So that would be again 8 feet per minute, and I'll call that medium minus 0.5 millimeter pressure on PVC. Standard 40-60 block. All right. Now, we're going to go to 6 feet per minute, and then we're going to switch to the aluminum, and we're going to use the rest of those. Actually, we have a little bit more. I have 2 of those. I have 1 more of these. Yeah. I wanted to run a few more of those lower on the ceramic blocks for you to see. But then we also still have here aluminum, 16 gauge, of course with the diamond plate on top. So we're going to have some effect on the diamond plate. Right? There's not much fur here for me as far as I'm concerned. Yeah, there's some fur here on this side. Okay. 6 feet per minute. So, we're going to bring this down. Potentiometer setting on board. 6 feet per minute. Again, I'm going to go up a quarter of a turn in order to have a little bit more rest on this side. Of course, now it's going to be a little bit longer time before the parts come out in the back. It's going to be about twice as long as the first pass. You can always on a machine like this, larger parts, especially longer parts, you can fill the table, of course. You want to leave about at least an inch between the parts so that the brush can cover. And if you put the 2 edges side by side, it's like so. So now here, you see how you have more rounding. You still remove very little material from the surface, so some of the small scratches you will always see in the material. So, and we are going to run the same side. Now we're going to remove, of course, more material. So this was 6 feet per minute, medium pressure, standard 40-60 block. And then on the, we're going to do this on the PVC, again minus half a millimeter. Alright, so this we have full both sides. So for this side, we're going to reduce the pressure by half a millimeter. I'm going to fill time until this comes out by writing on here. So that was 6 feet per minute, medium pressure, both sides. And the standard 40-60 block. Okay. And here you start to see how we aggressively remove some of the PVC. We're still not peeling it. But of course now we are getting really nice edge rounding. If that is acceptable to you, you get a very nice edge. But if that is already, that's about 1/8 of an inch, maybe 100,000. If that is too much exposure for you, obviously you need to go lighter and you need to go faster. Both of those labels. The aluminum, of course, even though it is thin, it's going to sit higher on this side, right? Because of the sleeve. So what we're going to do is, you can afford to be more further into the belt. I'm going to increase this to 2.5 in the thickness, 100,000. But make pressure here. No, and because it's aluminum, we're going to run full 11 feet per minute. You can hear, now you can really hear the brushes again, because we are sitting higher up in the bed. And we have some temperature in the part. Very nice and round, very safe. So when we do this side, you see how we change color here, right? You're going to see the same thing here, of course. And we need to reduce the thickness again because that edge, of course, is only sitting about 40 thousandths above the conveyor belt. So because it's aluminum, I'm going to reduce this a little bit, and I'm going to go back to the 1.5. The brush is going to glide over the ribs from the diamond plate. That's not a problem at all. But we need to make enough pressure to get to the edge. So this is what that looks like. Not totally terrible, but you can clearly see a grain in the top of the aluminum plate. Right? Some people may like that. The edges are clearly rounded. Right, we have a little bit less here, but still it's so that you won't cut yourself, it's safe. All the way around. And that's at 11 feet per minute. I'm going to do the same exercise now for you at 8 feet per minute, so you can see the difference. So that was 11 feet per minute. 11 feet per minute. per minute, which on the potentiometer is about a 4. Or, no, hang on. We're going to go to 8 feet a minute, 5 to 6. There. So, from the last setting, we're going to stick with that side first, and then we're going to increase the material height to 2.5 millimeters. Now we have a little bit more temperature in the material. And you see that we make a little bit more of an impression, right? So, we're going to go back to 2.5 here. All the way up. Like this. And again, this is about 8 feet per minute. Actually pretty warm, which means we have more pressure. Oh, sorry. 8 feet per minute. We have probably plus pressure, so heavier pressure here. And it's the standard 40-60 block. Okay. Because that's what you run, so that you can compare it to what you have right now. I'm going to keep the last two against for the ceramic oxide, which we're going to run on this machine, the combination machine, but it has the purple blocks on it. This is a 43-inch machine. So, go back to 10 feet per minute, setting going to 8 on the potentiometer, and start with this side. You can really hear the blocks engaging right now. But the blocks are about 100,000, 120,000 below the surface. That's ever so slightly in the position. So that's cooler because we ran, of course, 10 feet per minute, right? And again, that's the standard 46. See how quick and simple it is to adjust for the material thickness and to adjust for the brush pressure if you know where you're going. The hand adjustment is actually way quicker than the screen ever will be for an quick adjustment on the machine. And of course you can do it on the fly while the machine is running. So that's your result in 10 feet per minute. I think that's also very acceptable to you. You'll like that, right? We need to test what it really does when those things are PVC covered. We didn't have those samples from. So, now we're going to take a break here, and we're going to go to the purple ceramic one. Thank you very much. here we have our combination machine, which is a little bit longer because it has a white belt in front, but it has a purple blocks on it. So we've set that machine to 10 feet a minute, and we're going to use the 20 gauge here, which we have a lot of them. And I'm going to run 10 feet a minute at, so here now we have a light setting, 10 feet a minute. On the other side, this is where the burr is. I can feel it. No burr here, no burr here. So this is with a ceramic block, maybe a little bit more consistency around it. You may like that edge a little bit better. So now we're going to go here. Again, this is burr, no burr, no burr, no burr. This has no burr on this side. So this is all around really, really nice. You will like that. This was a burr side, and it has a smaller radius than here. You can see that on the white line, but it is still fully rounded. Okay. Now, so this was 10 feet per minute. P60 ceramic, and it was light pressure. So the only thing that we're going to change now is we're going to go, just so that you can see that on this side, we're going to go to 15 feet. Very on the conveyor from 3 to 4. And you can make you a machine with the speed setting range that you like. However, you can only manipulate that with the gearbox. So here, this was a burr side. This is still pretty much rounded. And this also, this of course has a larger radius. So now we're going to go PVC. You see that we have a little bit of a defect here on the PVC, so you're going to see that afterwards in the part. So 15 feet a minute. What I was saying is we need to do that with the gearbox speed setting, because the frequency inverter can really only run between about 17 Hertz and maximum 85 Hertz, maybe at the most 100 Hertz. So there you have theoretically a ratio of 5 to 1, maybe 6 to 1. So here you see this on the PVC side. That still looks pretty good also. So now, we are going to go to 20 feet per minute. So that was here, that was 15 feet per minute. Right? And important, this is a P60 ceramic. Now, and at the same time, I'm going to run the aluminum. So here, We have the burr here and here. Here and here is where we have the burr. And here, 3 sides. This is going to go a little bit harder because it's going to sit a little bit higher, so I'm going to start on this side. So now we're going to 20 feet. Conveyor, which means that I'm pretty hard in the conveyor too. So that, you need to be the judge of that, if that is enough edge rounding for you on those 2 edges. Here, this was the non-burr side. This one, sorry, this side, you see the scratch going across. This is in the aluminum, that is actually perfectly fine. Now we're going 20 feet a minute here, and we're going 20 feet a minute here. This is going to get hard, hit really hard because this is how much you elevate the edge. But it'll go through. A lot of temperature in the aluminum because, like I say, we pressed really hard on the back side because it was sitting that much higher. So that is 20 feet per minute. It's still a medium press, right? And it's a P60 ceramic. It's important that we write that on all of those because once we send them to you, you won't know which one was which. And that was also 20 feet per minute. This is, of course, is plus press and P60. And this is medium press. Because the edge sits lower. So now we're going to go all the way to 30 feet. Now we're being in a hurry to get to the other side. That, I am not sure if that is enough for you. You must be the judge of that. I think we still have the burr here on this side. And here we have the burr here, and we have the burr here, and here. So what I'm going to do is I'm going to show you basically, I'm not sure that these arrows, but at 30 feet a minute, it may be that we still see those arrows basically pointing to the burr side. You see the scratch on the top? You still see the arrows? That's how little material we are removing. And then you can be the judge what these edges look like. These ceramic blocks, of course, are super aggressive. So, but now what I'm going to do with the last part, in order not to be so much in the conveyor belt, so this is 30 feet per minute. 30 feet per minute. Medium press. P60 ceramic. Now we're going to take the last one of these thin ones in order not to be so heavy in the conveyor belt, and I'm going to come up by about 0.4 millimeters. And you can hear in the sound of the machine that it's going to be a little bit lighter. And but I'm going to go back to about 20 feet per minute. That is very light. Again, I'm not sure if this is good enough for you. So that's 20 feet per minute, light press. P60 ceramic. And we're going to do the same thing here. Again, the burr is on this side. There's no burr here. There's no burr here. Don't ask me why. And there's no burr here. The only burr that we have is right here. And actually what I'm going to do is I'm going to run this perfectly parallel so you can see what happens with your longer parts is you have to run parallel with that burr. So 20 feet a minute, light press. Not bad actually. So feet per minute, light press, P60 purple ceramic. That was a long way to write this out. And this is your belt direction. So it's perfectly parallel to this edge, and you can be the judge of that edge. Okay, so which is going to make it a lot easier, of course, on the machine, is if we now increase material thickness really quick. 2.5 for this one. There we go. So this is the aluminum perfect ceramic. With a little bit less pressure, we're not going to have as much heat in the part. It's going to be much more dense. See that? 20 feet per minute, light press, P60 ceramic. Now we need to go to the other side. For the other side, we need to go down 1.5 again. Otherwise, we won't hit that edge below the what we really want to see is you see these striations in here, which means we are hitting the base material, and this is why we have an edge rounding here, right? So this is set material thickness. I'm going to call that S for material thickness, right? S equals 2.5, and that is S equals 1.5. Now we have a 60 gauge, basically this material too, this thickness setting. So I'm going to run at 20 feet per minute with this up. Again, this is a light setting, and then you can go a little bit heavier. And it may require that, so if that's not enough for you, I perfectly understand, but we can do a lot more. So 20 feet per minute, light pressure. P60 ceramic. So on the other side, where we have the burr here, here, and here, not here. So these three sides. I'm going to run this one right behind it, so that's medium pressure now. Much better edge towards here. And there you also see we removed a little bit more of the PVC coating, which means this is more reliable. So this is at 20 feet per minute. Medium pressure. P60 ceramic. Same thing here. So now, just so that you can see, this is the last side that we haven't done. We have a burr here, here, and a little bit here. Not much here. But this is where the burr is on this part. What I'm going to do here, with the same pressure on the ceramic block, I'm going to go straight. I'm going to go small. Okay, I'm going to go about, let's say, I'm going to go about 10 feet per minute with the higher pressure. Okay, we'll run that in a little bit faster. Let's turn the speed down. There we go. So this is this part. You see everything has been labeled. So when you watch the video, you can follow the part. So now here we have temperature again in the part, good thing. A very homogeneous surface. And we have a big white line, which means we have a lot of edge rounding, just so that you can see that. So that's about 10 feet per minute. That's what you would have to compare to your current machine at 10 feet per minute and see if you get the same edge rounding. And that's basically the efficiency of the crossbar. It's time that this is the last sample because this thing is going. It's 60. Ceramic, medium pressure. All right, thank you very much. And that should conclude our business for those